Hello students, welcome to chemistry class of class 9. Today I am going to start the new topic chemical reactions and equations. So in this chapter you are going to learn about reactions that takes place between various chemicals and the principle that lies behind. Along with this you are going to consider the few situations of our daily life. So here they are. The first one is the first case. When a milk is left at room temperature during summer, since the temperature in the summer season is very hot, you have to imagine and guess what happens when milk is left at room temperature in summer season. Then another case where an iron tawa, pan or nail, and for such case any iron material that is left exposed to humid atmosphere. You all know what is a humid atmosphere. It's a humid atmosphere means it's a temperature or air that contains water vapor in them is known as humid atmosphere. So what is a humid atmosphere? Atmosphere that contains water vapor in the air is known as humid atmosphere. So imagine the situation when an iron substance is left exposed to humid atmosphere. What happens? You have to recollect. Then when grapes are or grape juice, when it is left over, what happens? Food that is cooked and left, what happens? And the food that we intake, after taking inside, what happens? Where it goes? It goes to intestine and there it gets digested, and after digestion we get energy. How do we get energy? So we have to think. And during respiration, what happens? Which gas we take and which gas is given out by us. So imagine all these situations and what happens. So here when we go back, the first reaction when milk is left at room temperature in the summer season is it gets spoiled because of high temperature. So we need to boil it and keep. Then an iron tawa or an iron substance, when it is exposed to atmosphere, it gets rusted. Same thing, grape juice, it gets fermented, whereas food that is cooked gets spoiled, and the digested food gives us energy, means it gets converted and gives us energy. And during respiration we take oxygen and gives out carbon dioxide. So in all the situations the nature of the substance is changing. The nature of the substance which we have taken in the initial stage had changed. So now let us try to understand how these reactions or why these substances gets converted and what the reaction is taking place between them. So now to understand it, let's understand the reaction that takes place between sodium sulfate and barium chloride. So what are the chemicals we are taking? Sodium sulfate and barium chloride. So here you can see sodium sulfate, which is colorless solution, and for this activity we need boiling tubes, solution of sodium sulfate and solution of barium chloride. So here are the test tubes, boiling tubes which can be used as a boiling tubes are taken, and solution of sodium sulfate you have seen already, which is a colorless. Even barium chloride is also a colorless solution. Now take little amount of sodium sulfate solution in a boiling tube and add this to barium chloride. Then on adding barium chloride solution to sodium sulfate, a white colored precipitate is formed, and this precipitate is barium sulfate. So here you can see that the precipitate is formed, and to this precipitate what we have to do is let this precipitate be left over for some time, means let it remain without disturbing. Then after 10 minutes you can observe that the white precipitate in the test tube settles to the bottom. As you can see here, the thick white precipitate After 10 minutes becomes clear to certain level, and at the bottom of it you can see here you can see at the bottom of the test tube the precipitate remains. Now decant the upper solution in the boiling tube into the beaker. Means you have to separate the clear solution, upper solution, from the boiling tube to beaker, and to this you have to add, to the precipitate we have to add dilute hydrochloric acid. And when few drops of hydrochloric acid was added to it, you have to shake the test tube. Then what happens is, we can see that the precipitate does not dissolve. It remains as a thick precipitate only. So what we can say is a chemical reaction has taken place already between sodium sulfate and barium chloride and forms barium sulfate, along with the formation of sodium chloride. So the thick precipitate is a barium sulfate and above it is sodium chloride. So here is the equation that takes place between the two compounds, that is sodium sulfate and barium chloride. So reading of the chemical equation is also important, equally important to writing the equation. So here how to read it, see. Na2SO4 plus BaCl2 gives rise to BaSO4 plus 2NaCl. Since in the molecular formula of Na2SO4 two sodium atoms are present, you have to read it as Na2SO4 and barium chloride BaCl2. So when these two compounds react, it forms barium sulfate, that is the thick precipitate, white precipitate, above it sodium chloride solution. Since in this reaction the two compounds sodium sulfate and barium chloride, they gets decomposed to its ions, component ions as sodium and sulfate ions, barium chloride as barium and chloride ions. They react together and forms barium sulfate and sodium chloride. So here, since two compounds are decomposing, this is known as double displacement. They decompose and again displace. Now as I said, double displacement, what is this reaction, what is the type of this reaction, how it takes place, and why we are calling it as double displacement reaction, I will be explaining you in the further class. So here you can see that in this double displacement reaction, sulfate ions are displaced by chloride ions. Sulfate from Na2SO4, they gets displaced by chlorine and forms NaCl. Same way, chlorine ions from barium are replaced by sulfate and forms barium sulfate. Okay, now another reaction that takes place between zinc and hydrochloric acid, or you can take sulfuric acid. So here you can see that this is a conical flask, and at the bottom of the flask you can see zinc granules. Above it is dilute sulfuric acid, H2SO4, which is known as king of chemicals. This sulfuric acid is known as king of chemicals. So here sulfuric acid is taken in the conical flask which contains zinc granules, and this conical flask is fitted with a one-hole rubber cork through which glass tube passes. So what happens is, when zinc granules are taken in the conical flask and sulfuric acid is added into it, and this conical flask is fitted with a one-hole rubber cork which contains glass tube, then within few minutes the reaction starts, and here zinc reacts with sulfuric acid and forms zinc sulfate. It forms zinc sulfate. Along with that, hydrogen gas is also released. So this hydrogen gas, you can see here H2 gas near the rubber cork through the glass tube. This hydrogen gas escapes out, and the hydrogen gas that is coming out, it comes out through the opening end of the glass tube. And when you put a burning splinter near to this open end of the glass tube, the matchstick that was brought near to it puts off with a pop sound, with a sound, and the splinter puts off. So this shows the presence of or the release of hydrogen gas in the reaction, because hydrogen doesn't help for suppression of combustion. So hydrogen gas puts off the burning splinter, and we can say that the reaction has taken place between zinc and sulfuric acid. Now let's see the third reaction. Take 1 gram of quicklime, that is calcium oxide, in a beaker. To that add 10 milliliters of water. Then what happens is this quicklime dissolves in water and it forms colorless solution. And along with the formation of a colorless solution, it was observed that the temperature of the solution increases, because when you touch the beaker in which the quicklime and water are mixed, when you touch it, we can feel the hotness of the beaker. So here the temperature has risen after water is added to quicklime. So from these activities we can say that sometimes there is a color change, and sometimes state of the substance like powder gets dissolved in the water and forms a solution. So there is a change in the state, and sometimes change in the color, sometimes evolution of the gas takes place, and sometimes change in the temperature takes. So all these changes that we observe in these chemical reactions or in general also leads us to study various types of chemical reactions that takes place in this chapter. So in the next class we are going to learn how the various chemical reactions can be classified. Hope you have understood this. We'll meet you in the next class with the classification of chemical reactions. Thank you.